Welcome to clickmyproject.com. Our project title: Least Cost Influence Maximization Across Multiple Social Networks. Our project abstract: recently in online social networks, the least cost influence (LCI) problem has become one of the central research topics. It aims at identifying the minimum number of seeds user who can trigger a wild cascade of information propagation. Most of the existing literature investigated the LCI problems only based on an individual networks. However, nowadays, users often join several OS and such the information could be separated across different networks simultaneously. Therefore, in order to obtain the best set of seed users, it is crucial to consider the role of overlapping under these circumstances. In this article, we propose a unified framework to represent and analyze the influence diffusion in multiplex networks. More specifically, we tackle the LCI problem by mapping a set of networks into single, one via lossless and lossy coupling schemes. The lossless coupling schemes preserves all properties of original networks to achieve high quality solutions, while the lossy coupling schemes offers an attractive alternative when the running time and the memory consumption are of primary concern. Various experiments conducted on both real and synthesis datasets have validated the effectiveness of the coupling schemes, which also provides some interesting insights into the process of influence propagation in multiplex networks. Our data flow diagram. In this process, we want to calculate related to the network. It can be a wired or wireless network. In the wired network, in our process we have done in a wired network. In the wired network, the series and the users can be calculated. In this process, seeds and users can be mentioned that are later process flow. Regarding to the data flow of the users, the seeds, if the series is more than the users, the flow can be as much as good later and makes that more efficiency and the process done in it. Our process flow makes that related to the greedy algorithm. In this process, using a greedy algorithm, the related series and the users can be calculated. The series and the user mention that the related neighbors in the network, and the source and the destination can be selected. The nodes deployed can be mentioned that the networks that can be created in the process, and the file can be chosen, and the nodes can be chosen, and the calculated distance can be provided. That the related greedy algorithm can be mentioned in that. The greedy algorithm can be using the greedy algorithm, the seeds and the users can be separated, and the delay count can be calculated. Regarding to the delay count, the resulting data can be provided, and the resulting data, the process mentioned that the flow and the certain conditions to be mentioned. The graph can be mentioned that the number of users and the delay count on the processing time in data. During the delay count is reduce the delay count, the series can be used to process the flow as much as possible to get the data from the user source to destination. It makes the more efficiency of the users. Certain delay count can be reduced regarding by calculating the series and the users of the certain process in the flow. Then the flow mentioned that the main process is the calculating the seeds and the users. Regarding to the seeds, the flow efficiency can be increased. By increasing the flow efficiency, the delay time can be reduced. The process can be further as a more efficiency to get the data as soon as possible from the source to destination. Our project demo for least cost influence maximization across multiple social networks. Click on home.java and click on run file. This is our home page. Click on, if you are a new user, click on a new user. If you are an old user or existing user, give your name and the password to make sure and login, and click on login success. If you are a Twitter data, If I am using a Twitter network, click on the Twitter network or click on FSQ processor. I am using a Twitter network, it can be wireless, and an FSQ it can be wired. Twitter processor, and the network can be created, and the network can be deployed in it. If I am a source process, this is the total number of seats in a destination. This is the total number of nodes created, and the file can be transferred in it choosing any of the files. The file in a content. After that, in the network we have to split the files. Files can be split with the total number of nodes and the files, and this is the file splitter with the number of the path stored, and the distance can be calculated using the seeders and the nearby users. The path can be selected, and the file can be used using the seeders. The file can be transmitted. Click on the node. This makes that the file prediction file can be received. Click on the node3.java. This makes sure that calculate the efficiency of the time and the file receive process. And right click on the destination. The file can be received, and the receiving file and the file can be merged. In this process, the delay can be calculated and the time can be calculated. This graph it mentioned that the users, total number of users, and the seeders. The seeders can be more than the equal to the users, so that the processing time can be less. The seeders can be increases related to the process time can be calculated. If the users is less than the seeders, means the processing time should be 0.1 seconds or certain to the, and the seeders is equal to the users, so the processing time and efficiency can be increased related to the process flow. And in this graph also provided the certain processing time, it makes that the efficiency of the file transfer from the one user to the other user using the seeders. Seeds the file can be transferred as more than the possible. Thank you.